This online class, I'm still here again to what? Explain the properties of wave. We have discussed on wave and classification of what? Of wave. Now, we are now here to explain what? Properties of wave. What are those properties of wave? Listen to now. We have 5 properties of what? Of wave. Now, the short one is what? We call it what? R squared D. Everyone call it R squared what? R squared D. Where the first R is for what? Reflection. Second one is for what? Refraction. D is for what? Diffraction. R is for what? Interference. And P is for what? Polarization. So now, I would like to take it one after the other. Now, what is reflection for now? Reflection is the bouncing back of a wave. What is reflection? Reflection is the what? Is the bouncing back of a wave when it encounters an obstacle or a polished surface. Everyone now, what is the reflection? Reflection is the bouncing back of a wave. Reflection is the what? Is the bouncing back of a wave when it encounters an obstacle or a polished surface. For example now, when you throw a stone to a wall, that wall cannot absorb a ball you throw to the what? Wall. What happens in that case now? It means the wall is what? Sending back the ball from the what? Wall. That's meaning that the wall cannot absorb the ball. That is now, we explain what reflection. So let's go to refraction. What is refraction? Refraction is the what? Is the change in the direction of a wave due to change in speed. Everybody, what is refraction? Refraction is the change in the direction of a wave due to change in speed as it crosses the boundary between two media. Everybody, what is refraction? Refraction is the change in the direction of a wave due to what? Change in speed as it crosses the boundary between what? Two media. Now let us ask, this is a boundary between what? Let us put a boundary between air and water. Now when a light or a wave strikes this boundary, on getting into this water, it refracts. It what? It bends. Normally, this ray of light is supposed to be what? Moving in this direction. But what happens is there's a change in direction of this wave. The change in direction of this wave is called what? Refraction. The change in direction of this wave is called what? Refraction. Now, tell me now, what causes refraction? Change in speed. What causes refraction? Change in speed. So take note of that. Now let's go to what? Diffraction. Now, let's go to what? Diffraction. Now, what is diffraction? Diffraction. Please take note. Diffraction. Tell me now, what is diffraction now? Diffraction is the what? Is the bending. What is diffraction? Diffraction is what? Is the bending of a wave. When it what? The bending of what? What is diffraction? Is the bending of a wave around an obstacle or a tiny opening. Everybody, what is diffraction? Diffraction is the bending of a wave around an obstacle or around a what? A tiny opening. For example now, that's when you have a wave in this wave and there's a slit in form of this. So let's take this one to this slit and let's assume this one is what? The emergent or the incident wave. Incident wave. Incident what? Wave. And let's call this the emergent what? Emergent wave. Now take this now. Let us assume that this is a wave. Let us assume this is a what? A water. In that case, a water wave. Now, if this water is flowing in this direction and it comes across an obstacle here and there's just a tiny opening here, what happens to this wave of water? It what? It tries to change its shape in such a way to pass through this what? Tiny opening. In that process, whereby this wave is changing its shape of bending round to pass through this tiny opening, that process is known as what? Diffraction. It's like now. So this is the process of what? Diffraction. Now let's move to what? Interference. What is interference now? Interference occurs when what? Two waves of same frequency. Interference occurs when what? When two waves of what? Of same frequency superpose or collide. Everybody, when does interference occur? Interference occurs when two waves Yes. Now let's go to number 5 now. Polarization. What is polarization? Polarization is the process of making a wave to vibrate in a single plane or direction. Everybody, what is polarization? Polarization is the process of making a wave to vibrate in a single plane or in one direction. Let us know that you have a bulb. You have put a bulb in a dark room. Now, when you shine that what? When you on that bulb, that bulb is going to, the light from the bulb is going to shine to what? To all the direction of the room. Now, let's take this way now. Now that this is a light shining from a what? A bulb in all directions. Now, this light is unpolarized. Is what? On what? Polarized light. Now, if you want this light to move in one direction, we are going to use a device known as the polar or polarizer. Now, let's take it to be this way. Now, let's take my diagram. Let's take it on to what? The polaroid or polarizer. Now, what is the function of this polaroid or polarizer? It will make this light that moves in one direction to vibrate just in only one direction. So you're going to bring this light just in one direction. So this one is called what? Polarized light. It's called what? Polarized light. It's called what? Polarized light. So this is the what? Process whereby you have what? Polarized and unpolarized light. Please take note now. This property is the property that distinguishes between a transverse wave and a longitudinal wave. Take note. Under polarization, it is the property that distinguishes a transverse wave from what? A longitudinal wave. Please take note now. All what? Sound wave cannot be polarized. Why? Because it's a what? A longitudinal wave. Take note everybody now. All transverse wave can be what? Polarized. But longitudinal wave cannot be polarized. Please take note of this now. Thank you. So